Hello, my internet people. Thank you for coming to my webinar, Opening Pull Requests with AI for Infrastructure Problems. I'm here to talk about how AI can automate GitHub pull requests to fix Kubernetes issues and reduce manual effort. My name is Avi Kotlicki. I'm a senior software engineer at Robusta.dev. Robusta is an open source multi-cluster Kubernetes monitoring tool, and we've written a handful of open source tools. One of them specifically that we're going to be focusing on for this webinar is a tool called HolmesGPT. It's an open source AI agent for Kubernetes. And I'm going to start with discussing why it's so critical for platform teams to start using AI tools in order to investigate the root cause of issues and automatically open PRs in order to solve them. So the first is, as cloud environments get more and more complex, it ends up getting more difficult to find the root cause of an issue. A pod's not running as it should be, and instead of restarting the pod or checking the configuration, it could be 5 components connected away, a service, network issue. It could be so many things. So having an AI agent that can automatically gather all of the related information, find what's relevant, and find the root cause of an issue in under a minute not only saves time, but resources in critical moments of failure. And another reason is sometimes these issues are difficult to fix. Like I said, when one component is down, it could be related to, misconfiguration. It could be related to this needs to be resized. It could be that the person that's dealing with this issue doesn't even have permissions in order to solve that issue. So having an AI agent that is configured to assist with remediation with these sorts of things, the AI could go off, detect the issue, suggest fixes, and with the permissions you've already granted, open PRs to remediate that. Now, imagine, for example, you have a developer, and the developer is having an issue with their application. What do? They contact the platform team. If instead of contacting the platform team, taking more resources from the platform engineering team, they went off, asked an AI agent, why is my application not working? And the AI agent went off, investigated it, and said, listen, this is an infrastructure team issue. I opened a PR to solve it. Then suddenly you've freed up resources and the developer gets their solution faster. And alternatively, the AI agent could go off and investigate it and say, listen, this is a platform, this is an application level issue, and we are not equipped to solve this, and it needs to be solved on your end. Suddenly, this whole back and forth between a developer and a platform team is reduced to the matter of under a minute, and the developer already has what he needs in order to move on and remediate the specific issue he's having. Now imagine, if you will, you have an alert that goes off that's high profile and you're not near a computer. Instead of having to stop what you're doing and go near your computer, you could send a message to your AI agent saying, hey, I have this issue, remediate it. The AI agent goes off, investigates it, opens up a PR for your infrastructure, where all you have to do is send a message on your phone, accept the PR, merge it, and suddenly, without even having to put down your phone, the infrastructure issue is solved by using open source AI LLM agents. So introducing HolmesGPT. It's an open source AI agent for Kubernetes troubleshooting. You can run it locally in your terminal, or you can run it in your cluster itself. It can do practically everything that a platform engineer can do. It can go off and run kubectl commands. It can investigate third-party resources, traces, logs. If everything's not in your cluster, if you have something like databases and stuff like that, RDS can go off and query that. But the benefit of this is, instead of you having to go off and open 50 different tabs, look at 5 different tools, the AI agent can go off and run all of that. And you can even, in one place see, the investigation of RDS, the investigation of your logs, your traces, everything like that, in one unified area. And then it'll say, based off of all of the stuff that I found, this is the issue. and then it'll go off and open a GitHub PR. Is the new feature that I recently wrote. What we see here is an investigation flow of our AI agent architecture. Here we have our AI agent, and the way that we kick off an investigation will be either an alert that gets forwarded to our AI agent from Prometheus, New Relic, OpsGenie, PagerDuty, or a question. For example, our chatbot in Slack gets asked a question, or our UI or the HTTP API gets forwarded a request, and it kicks off an AI agent investigation for Holmes. Now, what Holmes will do is it'll take that request and it will forward it to your own LLM model or ours. And we support almost every model you can imagine. It will learn your runbook or architecture. If you have your own documentation, you can add that to the configuration of Holmes so it knows how you investigate it in your specific environment. And it goes off and it queries the observability data. For example, it can get Loki logs, tempo traces. It can run all sorts of kubectl commands to gather all sorts of observability data and cloud infrastructure data. For example, if you have AWS RDS applications, databases, the AI can gather all sorts of information on health of all of these things, Kafka, OpenShift, many more that aren't even here. I recently wrote something for Datadog. It can integrate with that and pull all sorts of third-party information about your applications, about your environment. And after it's queried everything, it forwards it back to the LLM, and it's able to analyze the data and find the root cause of the issue. It'll then print out a report of the root cause, the related graphs. Right now it's in beta. It'll print related logs and the evidence for that. And what I recently implemented was after it's found the root cause and analyzed it, it will remediate it with a GitHub pull request. I wanted to point out, I didn't specify on this previous slide, but Holmes doesn't pull in all the data every single time there's an alert. Holmes only goes off and pulls the relevant data whenever you have an issue or a query to the AI agent. And how does that work? So I'm going to, on the slide, discuss the LLM API tool calling. If you know what that is, you can skip the slide. So the way that tool calling works is it's an API for most LLMs where you pass it a list of tools that it can run and their parameters and a query. For example, you'll say, I want to do this. Here are the tools and here are the parameters needed. And the LLM will go off and it'll tell you which tool to run. You will run the tool. You'll add the parameters that the LLM specified. You get that output, and then you pass that output back to the LLM. And this way, we can run very complicated investigations that are very specific towards the issue or query. So the pod will, for example, run the AI agent will run a command get pods. It'll see the pod statuses, and then based off of these pod statuses, it'll say, I want to investigate this thing. And it'll go off and run another command. And that way the AI agent can drill down to the root cause of the issue by running command after command until it's gotten to enough contextual data to know the root cause of the issue or do whatever process you want. So here's a brief example of one of these tools. They're very simple. You can do it in a YAML. This example is a Helm tool where this is the name that we pass the LLM, so it can identify which tool to use. The description is the information that we pass to the LLM, so it knows, when to run this tool. For example, if we're trying to investigate a pod, it's not generally going to investigate a Helm chart for that, unless it's a Helm-related issue. So the description is very important. And then the command, it can be, here we have a binary of Helm that we're running. It can be bash command. It can be anything that you would want to run. I've written run bash scripts here. You can run, we have a Python tool system, so you can run more complicated commands. For example, I had to run a command that required very complex authentication to an API and then parse the output and stuff like that. So Python is fabulous for things more complicated, but for very simple things, you know, this is exactly how it looks. Very easy to add your own, configure it too. What I'm about to show you now is a live running of the agent locally. It's going to go off and investigate a Kubernetes issue and automatically open up a GitHub PR directly from the command line. As I mentioned, you can run it locally, you can run it in cluster. If you're running it in cluster, you can configure it, for example, to do something like on a specific Prometheus alert, go off and investigate it and automatically open a PR. But here we're going to be running it locally. Our code is written in Python, so all we have to run is Python Holmes and ask. We're using the ask command. There are multiple different commands. Ask is just for plain text, but for example, if we want to do something like pull in an alert from Prometheus, pull in an Ops Genie alert, get a ticket from Jira, you would have a different command for those to gather that information and then pass it directly to the LLM. And now I'm going to walk you through a bit of how we phrase the prompt in order to get our agent to do what we want. So I'm going to ask something very generic. What is the issue with my Stark Enterprise Consumer Pod? That's all it really needs, is what's the issue with my pod or application or deployment, and the AI agent with that will be able to go off and investigate it and get everything you want. But I want to get a bit more detail just so you can see how the agent's thinking, how the agent is running each tool and what it gets from each tool and why it runs these specific tools. So here I'm asking it in complete detail, cite all information related to the issue you've discovered and what you discovered from running each tool. Open a Git PR to solve that issue. So here the agent's running already. What we're seeing now is the prompt that the agent gets, and it was already able to go off and run a tool, get all the pods. As you can see, it even found the exact pod name and the namespace. I only said my application name. I didn't say the specific pod name, and the LLM was able to go off and find the specific pod that was having the issue. Went off and got the logs and the previous logs for the application. And then it went and listed the open PRs to see if there was already a PR fixed. We listed the files from our Git repo. It read the file that it needed to change from the Git repository, and it opened a PR, increased memory limit for Stark Enterprise's consumer to prevent from being killed. And here we have the AI output. The Stark Enterprise consumer pod in the Kafka namespace was frequently restarted due to being killed. The pod's memory limit was set to 100 mega, which wasn't sufficient for its operation, leading to frequent restarts. And then we have the investigation. We went and got the pod description. The pod was running and had a high restart count, 900 restarts. The last state of the container was terminated with the reason killed. Then we saw in the logs indicated the Python script was running, but eventually failed due to memory constraints. And we even checked the deployment configuration, and it sees that memory limit was set to 100, which is too low for the workload. So it went off and opened a PR to increase it from 100 to 200 in the configuration to prevent the kill. So let's go off and check my GitHub. We're just going to refresh it here. And here we see the PR that was just created. We have the description, we have the name. And we're going to go off and check that it actually changed the correct place in the file. As we see, it went off and it was able to make all these changes without any, user input, just saying go and fix this issue, and it went off and found the line. And all I would have to do as a platform engineer is check this, approve the change, or look into it. This entire repo is PRs made by my LLM. So let's go look at all the other pull requests. It was able to do other infrastructure changes such as right sizing the PVCs, scaling up replicas, all sorts of things like that. But what's most exciting that I want to point out is all of this can be automated. So when you do get an alert, when you do have an issue in your Kubernetes cluster, the LLM can go off, investigate it, and automatically open PRs to solve not just infrastructure issues, but all sorts of problems you're having with your configuration in your applications. So, how was it going off and opening those GitHub PRs? So, imagine like forget everything that's written here. Let's say you're opening up a GitHub PR. What do you need to do as a person to go and open up a GitHub PR? You need to be able to, see what files are there. You need to be able to read files. You need to be able to make changes to the file and then like look at the changes that you've made, make sure that you've changed the right line or something like that. And then you need permissions to open a PR, and also you need to check to see that existing PRs exist, because you want to make sure that you don't duplicate another developer's work on your team or something like that. So I did all of that. I wrote these tools for the AI agent. I have it listing the files that are in the repo, reading a specific file, dry run a commit that's it's making a change without actually doing the commit. So it can see, that it's changing the correct line and pass that back to the LLM. The LLM will look at that change and say, oh, we changed the right line, or no, we didn't change the right line. We're gonna, do it again, because sometimes LLMs can make mistakes. So I found that double checking itself is fabulous. You can open a PR. We don't want it being able to merge just open PRs, because, for example, what if the LLM has changed the wrong thing, made the wrong fix, or something like that? So you want human intervention to check the PR to make sure that it's good before it does that. And then checking existing PRs. Sometimes someone else already made a fix. Sometimes someone already ran the AI agent and there's already an open fix. So you don't want to open like a billion PRs. And since I implemented this, I've been so happy. It reduces noise. Um, I want to say some of the security concerns that I had was I don't want my AI agent to pull my GitHub repo to my file, to my storage, for example. So I have everything, the listing files, the reading the files, the making commits, everything's done remotely. The AI agent is not pulling the entire GitHub repo. It's only reading uh, the individual file that it needs. So your secrets are protected. You can even, make it so it doesn't have access to specific files or things like that. I'm using a fine-grained token in GitHub to only give it access to a specific repo, specific permissions, specific commands. So that way I don't have to worry about it accidentally changing anything that I don't want, or any places I don't want it to change. And like, what are the next steps for GitHub AI changes? So with right now, working on very simple Helm charts and deployments, services, Kubernetes like full YAMLs. But when you're dealing with very complicated Helm charts that have they're pulling in other Helm charts too, you need more complicated logic to support that. So we want to be able to support much larger Helm charts, uh, even smarter PRs. Maybe make right now where we're only doing one or two changes in a file, but let's say this file we want to change 5 to 10 different commits and things like that. That's something a human can do, but the AI agent at this stage is having issues making larger changes to the file. Um, we want better commit structuring, and even AI assisted PR reviews. Imagine you have something that you're changing in your Argo CD repo, and you want the AI to go check to make sure everything is configured properly and no one's doing a typo or anything like that. The AI can run off, check your Argo repo, and just check off the PR before another developer looked at it. It can save lots of time, or even add comments to issues that are there. So you can try us out. We're open source. HolmesGPT at GitHub. here. You can message me if you have any questions. We're adding new integrations to this every single day. So, the other week it was GitHub. The other day was Datadog integrations, CoralLogix. So by the time you get around to trying it, we may have integrations for everything. Thank you for listening to me. And if you have any questions, feel free to reach out and connect with me on LinkedIn. And yeah, stay tuned for new exciting AI stuff. Bye.